Okay, we already talked about the special rule of multiplication, which requires that the events are independent. Now we move to talk about the general rule of multiplication, which requires that the events are dependent or are not independent. So if you look over here, we say the general rule of multiplication, it is used to find the joint probability of two events when the events are not independent. So here we're talking about two events that are dependent. Given that we have two events A and B, two events are A and B. When event B occurs, after event A occurs, A has an effect on the chance that event B occurs, then A and B are not independent, that is, they are dependent. So here we're talking about when, for instance, we select, an outcome without returning it, then the probability that another outcome is selected, of course, it is going to be affected. The probability of the second outcome being selected is affected by the probability by the occurring or the occurrence of the first outcome. Okay, so now we say that two events are dependent if the probability of the second event is affected by the occurrence of the first event. Therefore, the general rule is stated as follows. Say we have two events A and B, then the probability of A and B, that is the joint probability of A and B, both occurring, is equal to the probability of A times the probability of B, given that A has occurred or has taken place. Probability of B, given that A has taken place, is called the conditional probability. Probability of B, given that A has taken place or has occurred, is called the joint probability. Therefore, probability of B, given that A has occurred, conditional probability of event B taking place, given that event A has taken place. Okay? Now, let's give an example to illustrate the concept of dependency. Okay? Now, given that there are 10 books in a box, 6 are history and 4 are economics. So we have a total of 10 books in a box. 6 of those books, of these books are history and 4 are economics. A book is selected from the box. We select a book from the box. The probability that the selected book is history, of course, we have basically 6 books in the box that are history. So the probability that the selected book is history is 6 over the total number of books, which is 10. 6 over 10, which is, of course, 3 over 5. And the probability that it is economics, we have actually 4 economics books in that box. Therefore, the probability that the selected book is economics is 4 over 10. 4 over 10, which is 2 over 5. Now, the conditional probability that the second book selected is history, we stand for it H. Given that the first book selected is history, so we select the book, the first one is history, we did not return that book, so the probability that the second book selected is history, of course, is affected because we did not return the first book. So it's equal what? It is the conditional probability. So probability of H2, that is the second book selected, is history, given that the first book selected is history, is equal 5 over 9. Why? Because after the first book selected, the total number, of course, after the first book selected without returning it, the total number of books remaining in the box is 9. Of course, is 9. And because the first book is history, then the total number of history books, it has become 5. Therefore, we have remaining 9 books in the books, and 5 of them are history. Why? Because the first book selected is history. Therefore, we have at the beginning we have 6 history books. Now, after we selected the first book, that is history, then the remaining books, the remaining history books is 5. So, to determine the probability of 2 history books being selected, we use the formula above, which is the general rule, formula, which is here. Probability of A and B, the joint probability is equal probability of A times probability of B given that A has already occurred. So which is equal probability of H1 times probability of H2 given that H1 has occurred, which is equal 3/5 times 5 over 9, okay, which is equal 15 over 45. Usually when we have a large number of possible outcomes, it is easier to facilitate the process of counting by following these 3 counting principles or counting formulas, which are the multiplication formula, the combination formula, and the permutation formula. So let's talk about the first formula that is used to count the possible outcomes in an experiment. The multiplication formula, it says if there are m ways of doing one thing and n ways of doing another thing, then there are m times n ways. We multiply the the ways or the possible outcomes in each arrangement. So we have m times n ways of doing both. So the total number of arrangements or possibilities is equal m times n. Let's give an example of the multiplication formula. Of course, don't get confused with the multiplication rule, that we used before. The example 1, it says if a baseball manager has 5 pitchers and 2 catchers, how many different possible pitcher catcher possibilities can he file? Of course, we have 5 ways. Here we have 5 choices, 5 pitchers. Of course, in the first, when the baseball manager, chooses, and also he has 2 catchers. So the different possible pitcher catcher possibilities is equal, of pitcher, catcher is equal 5 times 2, which is equal 10. Okay? This is the total number of pitcher catcher, possibilities. So the total number of pitcher catcher possibilities is the multiplication of the the possibilities of pitcher and catcher, which are 5 times 2 equal 10. Now, the second problem is that a paint manufacturer wants to make several different paints. The categories consist color, red, blue, white, orange, yellow. So we have choices here. We have 5 choices in color. The type is oil latex. We have 2 choices in the type. The texture is that flat, high, gloss. So we have 3 choices here. Use, we have indoor, outdoor. The question, how many different kinds of paints can be made if you can select one color, one type, one texture, and one, of course, use. Of course, as you can see, we have 5 choices of color. We have 2 choices of type. We have 3 choices of texture, and we have 2 choices of use. So the total number, the total different kinds of paints. You can see here, answer of problem 2, total different possibilities of paint, of course, is equal 5 times 2 times 3 times 2. So we get 5 times 2, 10, times 3, of course, 30, times 2, we get 60. This is basically the total, different possibilities of paint would be the multiplication of all choices, in the questions, as far as color, type, texture, and use. Now we move to talk about the other kind of counting, which is the permutation formula, the permutation kind of counting. Remember that the multiplication formula that we used is applied to find the number of possible arrangements for 2 or more groups, such as the example we solved about the possible paints that the manufacturer wants to make. We have different groups. We have the color, we have the texture, we have the use. So we have different groups. Okay. However, the permutation formula is applied to find the possible number of arrangements when there is only one group of objects. We have one group of objects. Okay. Now, so permutation is any arrangement of R objects selected from a single group of n possible objects. Okay? The formula that will be used for the permutation is NPR, where n is the total number of objects in the group, and R is the objects, the selected objects from this n, from the total number of objects in the group, which is equal n factorial over n minus r factorial, where n factorial means n times n minus 1 times n minus 2. For instance, 3 factorial, which is equal to 3 times 2 times 1. Okay, so this is what actually we mean by factorial. We just multiply the numbers. So if we have permutation 5, permutation 2, which is mean here, we have the n is 5 and the r is 2, then it's going to be 5 factorial over 5 minus 2 factorial, which is equal, 5 factorial is 5 times 4 times 3 factorial over 3 factorial. So we cancel out the 3 factorial, we come up eventually with 20. So let's give an example to illustrate the use of the permutation formula. Now, say a news director wants to use 3 news stories on the morning show. If the director has a total of 10 stories, so we have one group that consists of 10 stories to choose from. Okay, so and here is 10. How many possible ways can the program be set up? Okay, how many possible ways can the director set up the program? Assuming that there is a lead story, a middle or a second story, and there is a closing story. Here we're talking about order. So when we use the permutation formula, we actually, require that order is present. So order is important here. So since order is important here, then the possible ways the program can be set up is we have n equal 10 and r equal 3. So the permutation of 10, the permutation of this type of question here, where n is equal 10, and the number of ways, the number of r selected from the n is equal, of course, 10 factorial over 10 minus 3 factorial, which is equal, when we simplify the the calculation here, we come up with 720, of course, possible ways. Now, the last formula that is used to calculate the counting, of course, is the combination formula. With respect to the combination formula, the order of the selection of selected object is not important. For instance, AB and BA are the same. However, for a permutation, AB is different than BA because the order is important with respect to the permutation. However, the order is not that important when we talk about combination formula. So here, the combination formula, if the order of the selected object is not important, any selection is called a combination. Therefore, the rule, the number of R objects combinations, the number of R object combinations from a set of n objects is calculated by using the combination formula, which is the C stands for combination. So it is the number of R objects selected from a set of n objects, which is the combination, is equal n factorial over R factorial times n minus R factorial. We already talked about factorial and what actually we mean when we say n factorial. Now we get here 2 examples. The first one is how many combinations of 6 objects are there taken 3 at a time. Of course, it's going to use the formula over here, which is C 6 3, which is equal 6 factorial over 3 factorial 6 minus 3 factorial, which is equal, of course, 6 factorial 6 times 5, let me see here, 3 factorial into 3 factorial. So here times 5 as you can see 3 factorial cancel out with 3 factorial, so we come up with 6 times 5 times 4 over 3 times 2. So we come up here with 6, 6. So we get here 20. We get 20. This is the answer of this equation. Now let's see the other one. The second question says an editor, a new magazine editor say, has received 10 books to review. He decides that he can use 3 reviews in his magazine. How many different ways can these 3 reviews be selected? Of course, we use the combination formula. So we get here 10, 3, which is equal to 10 factorial over 3 factorial into 10 minus 3 factorial, which is equal 10 times a 9 times a times 7 factorial over 3 times 2 times 7 factorial, 10 minus 3. So this one cancels out with this. So we come with 10 times 9 times a over 6. Okay? And here, come up here, of course, 3, 2, 3, 3. So we get here 24, 240 over 2, which is equal 120.